This video is on finding the highest common factor. That's what I mean by HCF over here. Yeah, highest common factor. And you might be thinking, well, why are we doing this? Well, we've just finished expanding brackets and now we're looking at factorizing. Factorizing is the opposite process of expanding brackets. It's where we put the brackets back in. So instead of expanding the brackets where we take the brackets out and multiply the terms, what we do is we get given an expression that is already in expanded form and we have to decide what is that common factor to both the terms and put that out the front of the brackets, and then we have to work out what terms go inside the brackets over here. And in order to work out what term goes out the front of the brackets, you need something called the highest common factor. Highest common factor. And that is the highest term that will go into both, or the largest term that will go into both of the two terms you have in your expression. Maybe you'll have more terms, so you'll have more terms to consider, but for now we'll just stick to two terms. And to think of the highest common factor, you really need to think about the numbers that are in the terms, and then you also need to think about the variables that are in the terms. Some terms might not have any variables at all. So in this example, we've got a 12 and a 20. Well, the highest common factor, if you have a 12 and a 20, that's the largest number that goes into 12 and 20, is 4. Okay, we can't choose 20. 20 doesn't go into 12, it's too big. And we can't choose 12. 12 doesn't go into 20 because it leaves a remainder. We need a factor, which means there can't be any remainder. We can't take an m out the front of the brackets because there is no m in this term over here, which means there'll be no m out the front of the brackets. So in this case, my highest common factor of both these two terms is 4. In our next video, we'll actually look at how to complete this whole question and fill in the brackets. But for now, we're just focusing on the highest common factor. So we'll look at a few more examples where we're finding the highest common factor. Here I've got a 15 and a 12. So the largest number that goes into 15 and 12 is 3. And I have an A and a B, and what I want you to notice is they're not the same variable. So we don't have a common variable. Okay, when we talk about highest common factor, it needs to appear in both the terms. So that's the end of it. The highest common factor is 3. Over here I've got a 20 and a 30. Well, the highest common factor of 20 and 30. Biggest number that goes into 20 and 30 is 10. I have an M common to both the terms, so I will also take the M out. Over here I have no numbers. I do have some numbers. I've got 1. If you have 1 and 1, the highest common factor is 1. So really there is no point in writing 1 down because 1 is like an imaginary coefficient in algebra. So if I write p, I know that it's 1p, but I don't really need to write that 1. So I'm not going to bother writing the 1 down. And I also have an m, and m and an m squared. Now this is where I want you to remember that m squared is m times m. So I've got an m over here, and inside the m squared I also have an m. And so that means an m is common to both m and m squared. So my highest common factor is m. I can't take another m, so I can't take m squared because this does not have m times m in it. So it must be common to both the terms. Over here, I've got m squared and m cubed, and I'm remembering that m squared is m times m, and m cubed is m times m times m. And so what I've got common, an m in both of them, and then I have another m in both of them, but that's it. Okay, I don't have any more common m's. So that means the most I can take out is the m squared. So if you look at this example, you have to take out the lower power because this one is too big. We don't have another m over in this term, so m squared is my highest common factor. All right, over here, let's look at the numbers, the coefficients. That's just the number in front of the variables. 28 and 42, what's the highest common factor? The biggest number that goes into 28 and 42 is 7. Hopefully you'll think you already thought of that. Let's look at the variables and look at what's common. A is common. D is common. And the remaining the remaining variable in both the terms, the B and the C, well, they're not common. They're not the same. So what we can take out the front is an A and a D. Now here's a very important rule. If both the terms in your expression are negative, if they are both negative, you must take out the minus. So straight away I'm pulling out a minus. If they're both negative, you must take out the minus. Then I can look at the numbers, 45 and 36. The highest common factor is 9. And I've got a g cubed and a g to the power of 4. So if you remember before, we were talking about how if you have the variables being the same, but we've got powers of them, you have to go with the lower one. And I can repeat, hopefully I've got enough room here to remind you that this g cubed is g times g times g. This g to the power of 4, see if I can squish it in there, is 1, 2, 3, oh, it's tough, 4, just got it in. So let's see what's common. 1, 2, 3. That's all I can take. I can only take what's common. I don't have a fourth g over in the first term, so I'm going to take the lower power of g cubed. So that is the first part of factorizing. You must be able to take out that common factor. Once you take out the common factor, or the highest common factor, you're already halfway there.